Hello students, this is a topic test. Now these topic tests have been designed for you to take once you've completed the basic concepts of a topic. You can take this test to analyze and understand how you are able to apply the concepts that you've learned in a timed manner. Once you've gone through a test, this video will help you get a perspective of what would have been a good attempt, which questions you should have attempted, and how you would attempt the questions in a test. And if you do like the test in the videos, there are more than 200 such topic tests that are available on the Bodhee Prep Android app. So the link for the app is in the description below. You can download the app and make use of these tests. This video is on the topic time and work. The test number 4 in the app this video is the analysis of that test. Overall, the test was moderate level of difficulty, and an attempt of net 6 questions correct would be a good attempt, would get you a 90 to 95 percentile plus. Attempt time, I mean, when I say attempt time, I mean the time required to go through all the questions. Out of them, get 6 correct, and maybe at least attempt the rest of the questions as well. The overall time for that should be about 20 to 23 minutes. Looking at the questions, the first question says, a tank has 4 inlet pipes such that each inlet pipe, while working independently, can fill the tank in 4 hours. The tank also has 2 outlet pipes such that each outlet pipe, while working independently, can empty the tank in 3 hours. So if we say that a tank, the capacity of the tank says 12 liters, the inlet pipe, because it can fill the tank in 4 liters, is filling 12 by 4. That is 3 liters per hour. And the outlet pipe, which can empty a tank in 3 hours, is emptying 4 liters per hour. We'll put a negative here because it is emptying. Also, there are 4 such inlet pipes and there are 2 such outlet pipes. If all the 6 pipes are opened simultaneously, then how much time will the tank get filled? Now, if all the pipes are opened, the inlet pipes will put in 3 liters per hour, and there are 4 inlet pipes, so 12 liters of water per hour. The outlet pipes will take out inlet pipes, outlet pipes. There are 2 pipes, each taking out 4 liters per hour, so they'll take out 8 liters per hour. Therefore, if all the 6 pipes are working, the net water that will get filled is 12 minus 8, 4 liters per hour. At this rate, we are filling a tank which is 12 liters. In how much time will the tank get completely filled? So 12 liters of tank at 4 liters per hour will take 3 hours to get completely filled. When all the pipes are working, option B becomes the answer. In terms of level of difficulty, it's an easy question. One of the most basic concepts in pipes and systems that we use. Solving time should not be more than 90 seconds because the numbers are also pretty simple to manage. Saral and Himanshu can do a work in 6 and 8 days respectively. Saral, Himanshu, Abhishek together complete the work in 2 days. What is the ratio of earnings of Saral, Himanshu and Abhishek? Now, there can be 2 ways of looking at this question. One is, let the total work be a multiple of 6, 8 and 12. Say 24 units. That means Saral does 24 by 6. That is 4 units per day. Himanshu does 24 units in 8 days, therefore 3 units per day. And if we look at Saral plus Himanshu plus Abhishek, together they do 24 units in 2 days, so 12 units per day. And therefore, if you look at only Abhishek, Abhishek would be doing 12 total minus 4 done by Saral and 3 done by Harsh. So 12 minus 4 minus 3, 5 units per day. They work for 2 days each. So the total work done by Saral, Himanshu and Abhishek will be in the ratio 4 into 2. 4 units per day, 2 days work is to 3 is to 2. 3 into 2 is to 5 into 2. 4 units work for 2 days, 3 units for 2 days, 5 units for 2 days. Hence, the work done will be in the ratio 4 is to 3 is to 5. And money will also be divided in this ratio. Option C becomes the answer. Alternatively, what we can say, if we look at Saral does the work in 6 days. So in 2 days, Saral will do 2 by 6 of the work, which is 1 by 3 of the work. Himanshu does the work in 8 days. So in 2 days, Himanshu will do 2 by 8, that is 1/4 of the work. And therefore, Abhishek will do 1 minus 1 by 3 minus 1 by 4. This comes out to taking the LCM as 12. 12 minus 4 minus 3, which is 5 by 12 of the work. 1 by 3 can be written as 4 by 12. 1 by 4 can be written as 3 by 12. So if we look at the ratio of the work of Saral, Himanshu and Abhishek, Saral does 4 by 12 of the work, Himanshu does 3 by 12 of the work, and Abhishek does 5 by 12 of the work. This is a ratio of 4 is multiplied by 12, 4 is to 3 is to 5. So these could be two ways of going about the question. And I think both the methods, pretty easy methods, should be able to do this in about 90 odd seconds. It takes 30 hours for an inlet pipe to fill an empty tank completely. When 5 identical inlet pipes, 4 identical outlet pipes operate together, the same empty tank gets filled in 10 hours. How much time will an outlet pipe take to empty the tank when it's filled up to half its volume? If we take the tank to have a capacity of LCM of 30 and 10, 30 liters, we see that one inlet pipe can fill the tank in 30 hours. So capacity of inlet pipe will be 30 liters in 30 hours. That is 1 liter per hour. Efficiency of an inlet pipe. Overall, when we have 5 inlet plus 4 outlet pipes, this is outlet pipes. The combined efficiency of these pipes is 30 liters being filled in 10 hours, therefore 3 liters per hour. But we know that every inlet pipe fills 5 liters per hour. So we can say 5 plus 4 into each outlet pipe is filling 3 liters per hour, which means the 4 outlet pipes are emptying 2 liters per hour, 3 minus 5, which means an outlet pipe empty is minus 2 by 4, that is minus 1 by 2 liters per hour, minus because it is emptying the pipe. Now we have to find out in how much time will an empty when one outlet pipe take to empty the same tank when it is half filled. If the tank is half filled, the volume that needs to be emptied is 30 by 2, which is 15 liters. One outlet pipe empties half liter per hour, so time taken will be total volume upon the volume emptied per hour. So 15, this is liter, this is liters per hour. And if we solve this, we'll get 30 hours as the answer. So half filled tank will be emptied by one outlet pipe in 30 hours. Because there are 2 steps involved and there is a group working, I would say maybe a question that is towards the moderate level, but in any case should not take about 2 minutes to solve this question. Not more than 2 minutes to solve this question. One man and 6 women working together can do a job in 10 days. The same job is done by 2 men in P days and by 8 women in P plus 5 days. What I'm assuming is that the total work, is 8 into P plus 5 units. This will make it divisible by all of these numbers, or all of these terms rather. Now, 2 men, suppose the efficiency of a man is M. So 2M working for P days will do the entire work, which is 8P into P plus 5. That means a man does 2 4s are 8, P and P cancel, P plus 5 units per day. Similarly, 8 women, suppose the efficiency of one woman is W, 8 women working for P plus 5 days are able to do the entire work, which is 8P into P plus 5. P plus 5 cancel, 8 and 8 cancel. So the efficiency of a woman comes out to P. Now, from the first statement, we know one man, this is units per day. One man means P plus 5 units. And 6 women. Sorry, this will be 4 here, not P plus 5. This will be 4 into P plus 5, 8 to... when we divide 2 by 8, we'll have a 4 remaining. Efficiency of a man will be 4P plus 5. Now it is 5. So one man means 4P plus 5 units plus 6 women. One woman does P units per day, therefore 6P. This is the work that is being done by one man and 6 women. If they work for 10 days, so multiplied by 10 unit per day into days, this will be the total work. Total work we have assumed as 8P into P plus 5. We get an equation in P, we can solve to get the value. So this becomes 4P plus 5, 4P plus 20 plus 6P into 10 is equal to 8P square plus 40P. 4 plus 6, 10 into 10. 100P plus 200 is equal to 8P square plus 40P, which means 8P square plus 40 minus 100 minus 60P minus 200 is equal to 0, which means divide by 4, 2P square minus 15P divided by 4 minus 50 is equal to 0. So we look for two numbers which have a product of 250s or 100 and a difference of 15. They will be 20 and 5. So 2P square minus 20P plus 5P minus 50 is equal to 0. 2P into P minus 10 plus 5 into P minus 10 is equal to 0. 2P plus 5 into P minus 10 is equal to 0, which means either 2P plus 5 is 0 or P minus 10 is 0, or which means P is equal to minus 5 by 2, which is not possible. Efficiency is not negative here, or P is equal to 10. So this becomes our only solution. So if you look at the efficiency of one man, putting the value of P plus 10 plus 5, 15 and 4, 60 units per day. Efficiency of a woman is P, which is 10 units per day. The question says, by what percentage is the efficiency of a man greater than that of a woman? So we are saying by what percent is 60 greater than 10? 60 is 50 greater than 10, so 50 upon 10 into 100, which becomes 500%, the answer option B. In terms of level of difficulty, I would say this is probably a moderate to difficult level of questions, even possibly towards difficult level. Even if we are able to solve it, it will take time. It will easily end up taking more than 3 minutes. So again, in an examination, you can take a call on such a question. At their usual efficiency levels, A and B together finish a task in 12 days. If A had worked half as efficiently as he usually does, and B had worked thrice as efficiently as he usually does, the task would have been completed in 9 days. So let us assume the work to be done as the LCM of 12 and 9, which will come out to 36. Suppose the efficiency of A is A, or we can take it as 2A because we have to find half of the value. Efficiency of A is 2A units per day. Efficiency of B is B units per day. Now, when A and B work together, the amount of work that they will do in a day is 2A plus B. And doing this, they'll be able to finish the work in 36 days. So we can say 2A plus B will be 36 finished in 12 days, so 3 units per day. So we get one equation as 2A plus B is equal to 3. Second, if A had worked half as efficiently, so doing A units per day, and B had worked thrice as efficiently, which is doing 3B units per day. In this case, 36 units would have been finished in 9 days, therefore 4 units per day. The next equation is 2A plus 3B is equal to 4. In how many days would A take to finish the task if she works alone at her usual efficiency? So what we have to eliminate B. So what we do is we multiply this by 3. We get 6A plus 3B is equal to 9. The coefficient of B is same. Take this, subtract it from here. 6A minus A is 5A, 3A, 3B, 3B cancel, 9 minus 4 is 5, and therefore A comes out to 1 unit per day, which means efficiency of A is 2 times A, which is 2 units per day. So if A has to do the work alone, these 36 units, the time taken by A will be 36 units being done at 2 units per day, so a total of 18 days will be required. Hence, option B becomes the answer. Again, moderate level of difficulty question. We have to assume values and then work backwards. And there are two equations. So the solving time would probably be about 2.5 minutes. The question can be looked at in the exam. 6 men can complete 2/3 of a work in 5 days. 6 men can complete 2/3 of 5 days. 6 women can complete 1/5 of the work in 3 days. And 5 children can complete 1/4 of the work in 6 days. If we assume that the work is 600 units, I am doing this because we'll end up dividing by 3, 5s, and 6 many times. Now 6 men can complete 2/3 of the work. So 2/3 of 600 will be 400. 6 men are doing this. 3 is gone. So 900. Let us take the work to be 3600. So if we look at men, they're doing 2/3 of the work. 2/3 of 3600. This will be 2400 units. 2400 units are done by 6 men in 5 days. So if the efficiency of a man is M, I can say 6 into M into 5. 6 men, 5 days do 2400 units of work. M will come out to be 2400 upon 30, which is 80. Efficiency of a man. In case of women, 6 women can complete 1/5 of the work in 3 days. 1/5 of 3600 will be 720. If the efficiency of women is W, 6 women, 6 into W, working for 3 days are able to finish off the work. And therefore, W will come out to 720 upon 18, which will be 40 units. So this is M is 80 units per day, W is 40 units per day. If we look at children in this question, 5 children complete 1/4 of the work in 6 days. 1/4 of the work will be 900 units. If the efficiency of a child is C, 5 children working for 6 days are able to do 30 units of the work. Therefore, C will be 900 upon 30. 5, 6 are 30, which is 30 units per day. In how many days can a man, woman, and a child complete the work together? If a man, a woman, and a child work together, the amount of work done in a day will be 80 plus 40 plus 30, which is 150 units per day. And therefore, time taken to do the work will be 3600 units being done at 150 units per day. 3600 upon 150, 0 cancelled. Multiply by 2. 360 into 2 by 30. 30, 12 are 360. So the answer will be 24 days. In terms of level of difficulty, the question would be maybe a moderate level of difficulty, might take up to 2.5 minutes to solve. Can be looked at. If proportionality is something that we understand properly, this question can be attempted. We could also have used proportionality from their work. For example, if you look at this statement, 6 men doing 2/3 of the work in 5 days. So 6 men, 2/3 work in 5 days. If one man had to do the work, the number of days will become 6 times, so 30 days. And if 2/3 of the work, and if they had to do the entire work, one man, the entire work, number of days will become 3 by 2 times. This will come out to 45. So from there also we could have seen the number of days required by each person to do the work and then work with the question. Assuming a larger value and then dividing gave me easier numbers which I could manage, so I followed the first method. John and David work on alternate days, with John starting on the first day. John does 12.5% of the total work on the last day, finishes the work. If John alone can do the work in 6 days, which of the following can be the number of days in which David alone can do the work? John alone can do the work in 6 days. John does 12.5% of the work on the last day. This is 1/8 of the work. And John finishes the work in 6 days. Now, if we look at these 6 days, we can say since John does the work in 6 days, in one day, John typically does 1/6 of the work. I'm saying let work be 48 units, divisible by 6 and 8. So efficiency of John per day is 1/6 of 48. That is 8 units per day. But on this last day, John has done 12.5%, that is 1/8 of 48, which is 6 units. Now, if we make cases, we could have a case where John comes in, then David comes in, and then John comes in to do the work. This is the last day, for example. Here, John will do 6 units. Here, on the first day, normally John does 8 units. So the remaining work out of 48 would have been done by David. 48 minus 8, 40, minus 6, 34. So David could be doing 34 units per day. The second case is when John and David work for 2 days each, and then John finished the work by doing 6 units on the last day. Normal days, John would have done 8 and 8 units. That means David would have done 48 minus 8 minus 8 minus 6, which is 22. 36. 2 days John is working, so John will be doing 18 units per day. Not 36. 26. 48 minus 8 minus 14 is 26. 26 John is doing in 2 days, so 13 units per day. Third case could be John and David have worked for 3 days each. 1, 2, 1, 2, 1, 2, and then John comes in. Normal days, John does 8 units of work. Last day, John is doing 6 units of work. So this becomes 48 minus 8 minus 8 minus 8 minus 6, which will be 26 minus 6, 18. So for David, the work left is 18 units, and David has worked for 3 days. Therefore, amount of work David will do each day will be 18 by 3, which is 6 units per day. Next is John and David work for 4 days together. John, David, or each of them. And then finally, John does 6 units of work on the last day. Normally, John is doing 8 units. In this case, David will do 8, 8, 8, 8. So this is 32 and 6, 38. 48 minus 38 is 10. So John is doing 2.5 units per day. 10 by 4. Now, in this case, amount of work or number of days required by David to do the work will be 48 by 34, which is just less than, which is just greater than 1. Here it will be 48 by 13, again a decimal, which will be somewhere between 4 and 5. Here it will be 48 by 6. 48 units, David does 6 units per day, therefore 8, which is one of the answers. Here it will be 48 by 2.5, which will become 48 by 2.5. Multiply and divide by 4. 48 to 4, 192 divided by 19.2. If we make further cases, John has already worked 1, 2, 3, 4, 5 days. The last case that is possible is John works for 5 days, David works for 5 days, and then John works on the last day to finish the job. Here 40 units of work will be done by John. Here 6 units. So David in 5 days is doing 2 units, in which case per day work will be 2 by 5, which is 0.4 units per day. In this case, David will take 48 upon 0.4, which will be 120 days to finish the work. So for different cases, David could be taking 48 by 34, 48 by 13, 8, 19.2, or 120 days to finish the work. From these, the only option available is C8. That becomes the answer. Again, moderate to difficult level of difficulty question. Cases will have to be made and then checked, and therefore the attempt time will also probably reach 2.5 to 3 minutes easily. There are 2 taps P and Q connected to a tank. P alone takes 16 hours more than the time taken by P and Q together to fill the tank. While Q alone takes 36 hours more than P and Q together to fill the tank, how many hours Q alone will take to fill the tank? P and Q, there are 2 P and Q connected, P alone takes. Okay, so here if we say that P plus Q take X hours to fill the tank, P takes 16 hours more, so P will take X plus 16 hours. And Q takes 36 hours more than P and Q, so Q will take X plus 36 hours. In this question, the value of X is simply given by X is equal to root of 16 into 36. Hence, the value of X will be root of 4 and 6, 24. How many hours will Q alone take to fill the tank? Q will take therefore 24 plus 36, which is 60 hours. How do we get this formula? In this case, the work done by P in 1 hour and the work done by Q in 1 hour, the sum should be equal to the work done by P and Q in 1 hour. P will do 1 upon X plus 16. Q will do 1 upon X plus 36. PQ together will do 1 upon X. Cross multiply X plus 36 plus X plus 16 upon X square plus 16 into plus 16X plus 36X plus 16 into 36 is equal to 1 by X. Again, cross multiply 2X square plus 36X plus 16X is equal to X square plus 36X plus 16X plus 16 into 36. 36X cancel, 36X cancel, 16 cancel, 2X square cancel. So we get X square is equal to 16 into 36, which means X is equal to root of 16 by 36. This formula can be used without any exception. Hence, directly use the formula to get the answer. Q will take 60 hours. P will take 24 plus 16, which is 40 hours. So if one takes 40, one takes 60, and we take the work to be 120 units, for example. If we take the work to be 120 units, one is taking 40 hours, so 3 units per hour. The other is taking 60 hours, so 2 units per hour. A total time together will be 120 by 5, which will also come out to 24. All we needed to know was this. Now, if we know the formula, this is a pretty easy question. Will not take more than a minute to solve. Even if we don't know the formula and we write this equation, should be able to solve it within about 1.5 to 2 minutes, because the quadratic need not be solved. The X term cancels out. A group of 10 men can do a job in 15 days. The group start working after every 3 days. They are joined by 2 more men. So if a man does 1 unit per day, the total work is 10 men doing 1 unit per day for 15 days, 150 units. The group starts working every 3 days. So from day 1 to day 3, the amount of work will be 3 days, 10 men are working, that is 30 units. From day 4 to day 6, every 3 days, they are joined by 2 more men every 3 days. So at the end of the third day, instead of 10, 12 people will work, and the work that will be done is 3 into 12, that is 36 units. From day, again after 6 days, 2 more men will get added. For day 7 to day 9, we will have 3 into 14, which will be 42. This becomes 108. Day 10, we will have 2 more people working, so 16 units. At the end of 10 days, if we look at the work done, 30 plus 36, 66, 106, 108, 118, 124 units has been done. Day 11, another 16 units. So 124 plus 16, 140. And therefore, on the 12th day, we will be able to complete 140 plus 16, which is 156 units, but we have to do just 15 units. So the entire 12th day will not be required. The work gets finished on the 12th day. Typically, in questions like this, we end up adding up to a point and then checking. Since here the addition had to have happened till only 4 levels, I'm saying a moderate level of question. But these kind of questions can take time. 10 workers started a job and worked on it for 10 days. 11th day onwards, a new worker joined them every day till the job was finished. It took exactly 20 days to finish the entire job. Now, if we look at the entire work, day 1 to 10, there were 10 people working on each day. So 100 unit, assuming that one man does 1 unit per day, 100 units of work got done. After this point, 11th day, there were 11 people working. 12th day, there were 12 people working. 13th day, there were 13 people working, and so on, because one person got added every day till the 20th day when there were 20 people working. So the total work here will be 100 plus 11 plus 12 plus 13 and so on till 20. This is 100. For the next 10 terms, I can take out 10 from each of them. So 10 tens are 100. Plus, I'll be left with 1 plus 2 plus 3 up till 10. 1 plus 2 plus 3 up till 10 is 55. So 255 units is the total work to be done when one man is doing 1 unit per day. Now, the same job has to be done starting with minimum possible number of workers. When it is known that the worker will quit the job, a worker will quit the job after every day. After the first day, how many days will it be required to finish such a job? So now what happens is n people start to work on day 1. After day 1, one person leaves. On day 2, n minus 1 people work. On day 3, n minus 2 people work, and so on till the last day where only one person will be working. After this, even this person will leave and job will not done. So we have to finish the job by till on this day. Now the total work done here will be nothing but 1 plus 2 plus 3 up till n. 1, 2, 3, 4, 5, 6 up till n. This is nothing but n into n plus 1 by 2. Sum of the first and natural numbers. This should be equal to total work done. So n into n plus 1 by 2 should be equal to 255 or just more than 255. So this becomes n into n plus 1 is equal to 510. If we look at 22 into 23, 484 plus 22, 506. 23 into 24. 23 into 24. Will be 552. But on the last day, 1 unit of work will get done. If the value of n is 22, n into n plus 1 will be 22 into 23, which will be 506. The work will not get finished. We'll not be able to do the entire work. If n is 23, if we start with 23 people, 23 into 24 will be a number more than 510. Now, suppose we start with 23 people. On day 1, 23 unit of work gets done, day 2, 22, and so on. The total work that can be done in n days will be 23 into 24 by 2, which will become 230 and 46, 276. We need to do only 255 units of work. So from here, we need to subtract 121. So the last few days of work will not be required. If we subtract the last day's work, 1 plus 2 plus 3 plus 4 plus 5 plus 6, this is equal to 21. So what we need is we need to start with 23 people, but they will not have to work till the end of the thing. The last 6 days of work is not required. And therefore, the total number of days required will be 23 minus 6 is 17. So basically on day 1, 23 people will work. How many days will it to finish the job in such a manner? Then 22, then 21, then 20, and so on till day 17, where 7 people will work. And at this point, the work will get finished because 7 plus 8 plus 9. So this is day 1, this is day 2, this is day 3, this is day 17. So in this manner, 17 days of work is required to finish the 17 days of work is required to finish the work. Now, in terms of level of difficulty, I'd say this is a question which is towards difficult level, because even if we crack 23 here, that is not the answer. We have to still go to 17. So I think a moderate to difficult level of question. In exams, it is very likely that we end up making a mistake with such questions. And therefore, if I look at the overall test, as I was saying initially, the overall level of difficulty will be moderate. 6 would be a good attempt. Net 6, and these 6 questions that I would look to do in the examination would be 1, 2, 3, 5, 8, 9. Which are these questions? Definitely doing this basic concept. Would have done this as well. Similar questions done earlier. Would have done this. Just making an equation and solving. This I think could have been left. Would have done this basic application of efficiencies. Again, here proportionality was required. So if I'm looking at 6 easy questions, this may or may not be one of the questions that we attempt. This I thought was a good question because cases were being formed. Would have done this because it's a straight formula that we are applying. Would have done this because I've done similar questions, and again the additions were fewer here, only 3 or 4, and we reached the number. This I thought was a pretty good question. Might not have done that in the examinations. For me, the attempt would be 1, 2, 3, 5, 8, and 9.